build mountain roads that won't fail.
I manufacture drilling equipment that is sometimes used to search for buried treasure.
I'm a geotechnical engineer. I drill, dig, and explore what's under the ground. I get really muddy.
I build. I design.
I educate.
I conduct research.
I'm an integral part of this dynamic team.
I manage major projects.
I calculate.
I supply specialty equipment
And materials.
I love what I do.
So, what do you think? Want to know more? I thought you might.
That was a very interesting video. A suitable introduction of how geotechnical engineering could act as the thin line that exists between a structure that is standing up and collapsing down. This is the reason why we even study the element of a structure responsible for transferring the loads to the ground, the foundation. Puro question mark na ba nagpa-pop out sa utak nyo? Don't worry!
Later, we will be greeted by a topic that is closely associated with foundations, specifically deep foundations in the form of piles. Lalaliman natin ang usapan, literal. So hold your breaths as we will be going down for real. But before all that, may we first call on Mr. Gerald De Lorente, the president of 4CB, to deliver the introductory remarks.
Good afternoon to everyone. It is my great pleasure to welcome all of you into our today's seminar with the theme of Consolidation, Compressing the Nose and House in Geotechnical Engineering. Before we get started, I would like to express my sincere appreciation to all of you who generously help us to make this event happen. I want to thank everyone here today for attending this event, Section 4 CEB for making this webinar possible, our professors for guiding us throughout the preparations, and our event speaker, Engineer Nicole Lane Tan, for accepting our invitation to impart your knowledge and expertise to everyone present today. I hope that by the end of the seminar, everyone will learn more about the AllPile software or the pile capacity analysis software that would help us in the future as structural and geotechnical engineers. Relating to our theme, consolidation, we are taught that in soil, consolidation refers to the process in which the soil volume decreases due to the applied stress or load. And with this process, it becomes stronger and more solid. Having said that, we hope that this event imparts you with the learnings and knowledge that would help our future careers to consolidate. Again, thank you, and a very warm welcome to each and every one of you. Let's make tomorrow great.
That was indeed welcoming, Mr. Class Press. We express our humble appreciation for that warm speech. Now, it is our pleasure to introduce everyone to our honorable guest speaker who had accepted our invitation for today's event.
Our speaker for today is a graduate of the University of Santo Tomas with a bachelor's degree in civil engineering in 2014 and is currently taking her master's degree specializing in geotechnical engineering at the University of the Philippines, Diliman. Her work environment is both in and outside of the Philippines. Her works include geotechnical assessment or evaluation and design of infrastructures, properties, as well as stability analysis of high-risk slopes, tailings dams, and special structures such as reclamation areas and ports and marine structures. She also has several involvements in the field of transportation, construction, structural design, and civil works. Let us all give a warm welcome to Engineer Nicole Lane B. Tan.
So, hello everyone. Good afternoon. So, thank you
afternoon
for
po.
the warm welcome, everyone, and thank you as well for the wonderful introduction. So, first and foremost, I'd just like to introduce myself. Well, yun nga na-mention na nila na yes, I am a graduate of UST last 2014 then and now I'm taking up my masters in UP Diliman, hopefully to graduate as well this sem. So please include me in your prayers, guys. So other than that, I think technical aside, yeah, wait, just some work background as well. I've been a geotechnical engineer for 5 years now. But prior to my career as a geotechnical engineer, I have some background in civil works because my first year as a civil engineer, I worked in a civil works company. And then eventually along the way, I found that geotechnical engineer is my one true love. So here I am now, still practicing the my specialization, and I hope everyone can learn. I hope to impart some knowledge to every one of you here about geotechnical engineering in general. So let me just share my screen. So please bear with me. There. Yeah. So please give me a confirmation or just reactions that you can see my screen right now. So I think everyone can see it right now. All right. So first and foremost, it's been a while that I've spoken in front of a large crowd. So please bear with my ums and us and some momentary stutters along the discussion. Sabi nga ni Adele, go easy on me. And thank you for your
Excuse me po, ma'am.
understanding. Ano?
Di po ata kita yung presentation.
So how about this?
Yan po. Kita na po.
Kita na?
Apo.
Alright. So first and foremost, thank you for inviting me once again. So as mentioned by our host earlier, this would be mainly a discussion on deep foundations. But before we dive into that technicality, let me just give you a brief background of geotechnical engineers. I think yung mga previous videos naman that the host showed were ample enough, but I've also added some additional information just so everyone could have a brief clarity on what geotechnical engineering is all about. So let me proceed. So mainly our outline of the presentation would be there would be 4 parts. So one would be the introduction, just some background of geotechnical engineering, scopes of work. And number 2 would be the quite a bit of a technical discussion about the foundation. So some backgrounds and some concept of it. So between part 2 and 3, I think I'll be turning it over to our host just because we have a commercial break prepared by them. So please watch out for that. And for our last part would be 3 and 4. That would be where I would be discussing kung ano ba talaga ang significance ng AllPile analysis and how is it applied to our lives as geotechnical engineers and how it is also seen in the geotechnical reports that we prepare. And for lastly, just some sneak peeks of what other geotechnical scopes, because baka isipin nyo na after nitong talk na to, deep foundation lang tayo. But no, there is more to geotech than that. So there. So first and foremost, the introduction. So I'll be showing a presentation here. So as much as I want everyone to be interactive on this, so please cooperate with me. I think you can see my screen right now. So please go to www.menti.com and use the code as you see here. And then usually kasi ang tinatanong is, first word that comes into your mind when you hear the geotechnical engineering. So automatic na yun eh, soil na yun. But now, I want to hear from you the second word that comes into your mind when you hear about the topic. So just please go to www.menti.com. I think there are straightforward instructions there that you can use, and you can enter the second word. Ayon. Yon. So foundation, landslide, money, really? Lupa, tres. Oh no, not tres. So yeah, soil stability, rocks, permeability, voids, geotextiles, yes. And the list goes on and on. Sir Olalo, sige lang. I'll give you 30 seconds more to input your knowledge about the topic. So, mahirap, no. No, what I aim in this talk as well is to let you guys realize that soil is really fun. Although lahat naman ata ng gagawin natin ay mahirap. Pero soil would be a very interesting topic to deal with. So, ayun. So, thank you for your inputs, guys, and thank you for this engagement. So, with all these, I think most of the words that you provided are right, and these are among the other terms that we will encounter as we go along the discussion. So thank you for that. So let me just get this back to my screen right here. So for the introduction, so geotechnical engineering is a specialization within civil engineering that involves investigating and understanding what is beneath the ground surface. Not only that, we also study the engineering properties of and behaviors of earth materials. So when are we actually needed? Actually, whenever there is construction or any establishments, we're supposed to be there. Geotechnical engineers are supposed to be the front runners when any development would be done. So basically, we are present even before the detailed design of a specific project. Kasi minsan, like in development projects, dapat nauuna tayo kasi mag-preliminary geotechnical assessment tayo on-site if the soil on the area is feasible enough na para tayuan ng massive structure, ganon. So pre-feasibility pa lang and due diligence studies, present na tayo. So some of the questions we answer is, how tall can we build the structure on this ground? As mentioned earlier by our host nga, diba? The integrity of the structure is mainly dependent on the behavior and strength of the soil. So ayun, it's also one of the questions we answer. And can we build a road here? That's also related to geotech. And if we cut through this mountain, will the slope collapse? So basically, these are just some of the typical questions that we provide geotechnical solutions to. So what are the scopes of work of geotechnical engineering? So among other things, we do soil investigation. So it is mainly focused on understanding the subsurface condition of the project site. Not only that, we also evaluate. So basically, from the borehole data that we get from the soil investigation, we can derive parameters from the scene subsurface profiles that we can use for design and analysis. Not only that, lalo na pag may data na tayo from the borehole data, we can also identify geohazards. So assessing the risk posed by the current soil conditions. So makikita mo kung liquefiable ba yung soil, magsasettle ba siya over time, and the likes. And also, our main topic for today would be foundation analysis. So as engineers, we always recommend the most efficient and effective foundation solutions to any problem. So additional 3 would be slope stability analysis. Of course, there are a lot of natural and man-made slopes, but we have to make sure that they are stable enough to withstand any earthquake conditions, saturated conditions and the like. And also, we are also concerned with the lateral support. So these are mostly seen on excavations, lalo na sa design ng mga, kunyari deep excavation. Kung hindi ganun maganda yung soil mo, kailangan mo mag-design ng shoring para hindi mag-collapse yung ground. And also, we are involved with ground improvement, which is mainly concerned with modifying and improving the soil properties. Lalo na kung napili yung site, medyo poor soil conditions ang makikita doon, or kung insufficient ba yung bearing capacity niya sa itatayong structure doon. So, just some visuals for soil investigation. So, I have mentioned earlier that our aim for soil investigation is to understand the subsurface conditions of the project site. So here comes the soil sampling by borehole drilling, as you can see on the topmost. I think you can see my cursor naman, no? So these are just these retrieved samples for borehole data, for borehole drilling rather, sorry. And this is an actual borehole drilling visual. So, meron tayong malaking rig, tapos hindi lang kita yung masyado equipment. Pero basically, ganyan yung setup pag nagbo-borehole drilling tayo. And what you see here is a test pit. So, test pits are usually done pag hindi masyadong, pag kunyari, we would need to know the California bearing ratio of the ground. So, basically, kung pwede ba tayong magtayo ng road dito, ayun, test pits ang ginagawa natin. So, among other activities sa soil investigation, of course, site reconnaissance. Kailangan talaga natin maging on-site and present para makita natin kung tama yung procedures na ginagawa ng mga subcons natin. So, field testing. Nandito yung mga field density tests and the likes. Then, soil sampling by means of open excavation, which are test pits or borehole drilling. Then, afterwards, yung retrieved samples na ito dadalhin sa lab for laboratory testing, for particle size analysis, moisture content, Atterberg limits, and geophysical explorations would be the non-invasive tests such as deep ground penetrating radar, which you would encounter naman in your courses as you go along. So, this is a typical evaluation. So, in hindsight, ang evaluation is kung meron na tayong borehole data, paano natin siya isi-simplify and paano natin siya bibigyan ng parameters para magamit natin in the design and analysis kung ano man gagawin natin na structure. So, this is, yun nga, yung typical na output ng isang evaluation. So we have the idealized subsurface profile na galing sa napakahabang and tedious borehole data natin. And from this data, magde-derive na tayo ng mga parameters na gagawin natin for analysis. So, identifying geohazards. So, yung geohazards, yun nga, yung mga risk na pwedeng mangyari sa soil natin, sa concerned project site natin, which are liquefaction, settlement, and consolidation. And makikita din natin dito kung expansive soils, expansive clays. Kasi yung expansive clays, medyo tricky siya. Hindi mo siya makikita at first, may specific test ka na kailangan gawin. Tapos, para makita mo kung, kasi kung nag-expand yung place, minsan nagkakakos siya ng cracking sa structure mo. And in some structures, hindi natin pwedeng mangyari yung mga expansive place na yun. Baka kasi sensitive sila sa movement. So, ayun, mag-a-assess din tayo. And some sinkholes potential sa mga karstic or limestone na formations underground. So, next would be foundation analysis. Ayan na nga. So, here comes yung mamayang main topic natin. So, foundation analysis, we're mostly concerned with shallow foundations, mat, combined, or spread foundations, and of course, yung deep foundation, which are piling works through board piles, driven piles, and micropiles. And then, just some additional background on slope stability. Syempre, titingnan natin kung yung slope can withstand the potential earthquake possibilities, or kung heavy rainfall. Kailangan natin i-assess yun kung magiging stable siya and not cause landslide na mapapahamak tayo in the future. And also, it also comes with the slope stability, yung recommendation ng slope remediation schemes if ever sa analysis natin deemed na inadequate yung slope natin on its own, kaya kailangan natin mag-apply ng remediations, mga measures such as soil nailing, benching, and piling works as well. And kung maglalagay din ba tayo ng mga mechanically stabilized earth or MSE walls. So lateral support, I've mentioned earlier, para mag-retain tayo ng mga mag-retain tayo ng earth structures, which can be for retaining walls, shoring in deep excavation, and contiguous and sheet piles usually can be seen in ports and maritime projects. And of course, ground improvement works, lalo na if yung binigay na site sa atin is medyo pangit yung lupa, kailangan natin i-improve siya. So by means of fibro-compaction, stone columns, PVDs, preloading. I believe na i-discuss naman to sa inyo ng mga profs ninyo. So please watch out. It's a very interesting topic in soil mechanics and geotechnical engineering. So aside from that, where we are working. So actually, as geotechnical engineers, since parang whenever there is construction, andyan tayo, here are also some sectors that we can be involved in. So unang-una sa infrastructures, we can be involved in railways, subways, expressways, tunneling. So minsan, like yung sa mga MRT7 natin na projects, andun tayo because we provide pile foundation recommendations to them. Aside from that, we're also involved with the maritime sectors, which are mainly concerned with establishing and constructing ports, marine structures such as piers and jetties, and reclamation areas as well. Lalo na ngayon, scarce na tayo sa lupa. So kailangan ng mag-study further na mag-extend ng land through reclamation areas. We're also needed there kasi parang man-made land lang siya. So, i-assess natin lahat ng risk imposed sa land na yon pag nagtayo na tayo ng structures. So, in the energy facilities then, we're also involved there sa industrial facilities and power plants. Mainly, of course, dahil sa dalawang locations na yan, usually tinatayo to sa mountainous area. Siyempre, as geotechnical engineers, kailangan natin ng slope stability analysis kung tatayo ba doon ang structure. And then sa development, mga property development, mass housing, so mga condo units or mga mass housings like yung ginagawa ni Villar, mga camellia homes, andun din tayo for feasibility studies and typical foundation design ng mga bahay doon. Then sa aviation as well, we can also be involved. Lalo na ngayon yung sa Bulacan Airport kasi ang site ng Bulacan Airport ngayon ay reclamation area. So medyo interconnected din ng aviation doon sa reclamation area na yun. Lalo na masyadong malaki ang load na kine-carry ng airports. So kailangan ng intensive geotechnical study concerning settlement analysis and foundation design nung tatayuan na future airport natin. And among other things are dams, reservoirs, and minings. Tapos itong mga sectors na to, mainly concerned din sa stability ng mga natin doon, mga slopes. So let's get into the main topic of the seminar, which is deep foundation. So basically, bago tayo mag-dive into the software, kailangan muna natin ng brief background sa deep foundation. I understand na I think currently kinukuha nyo ang foundation engineering and some audiences na present dito ay lower batch. So let me just provide you a brief background of what deep foundation is para makarelate din tayo sa gagamitin nating software later. So deep foundation are structural members of timber, concrete, and or steel used to transmit surface loads to lower levels in the soil mass. So pile foundations used for are mainly used for very large design loads, poor soil condition, at shallow foundation, or any site constraint. So just some types of deep foundation are driven piles. So driven piles usually are the precasted piles tapos installed lang by an drilling equipment sa site. Kaya driven siya kasi pile driving works ang mangyayari para ma-install siya sa ground. So other than that, drilled shafts. So drilled shafts are commonly called bored piles rather. So bali, magdidig muna tayo ng cylinder hole within the ground. Tapos after nun, saka tayo magpo-pour ng konkreto para ma-build ang bored pile natin. So usually drilled shafts, ideal siya for very large pile foundation with very large diameters. So typically sa mga railways siguro to makikita. So caissons are actually very deep and wide foundation. As you can see on the lower right, teka, ang cursor ko. Ayan. Ayan. So, parang massive talaga siya na deep foundation. Mostly supporting very large structures. So, hindi wala pa kasi akong personal experience dito, but I'm assuming nasa ports area dito siya. Gumagawa siguro sila ng very big facility along a pier on an offshore site. So ayun nga, dahil deep and wide foundation siya, may excavation works din na nakikita on the side, and ayun nga, napakalawak yung foundation system niya. And then for piers naman yung mga piers sa bridges. So yung applicability ng deep foundation, hindi naman din laging pwede na kunyari gagawa ka ng structure, mag-deep foundation tayo. Wag ganun kasi costly din ang deep foundation. So ideally, we use deep foundations for poor soil conditions. So kung compressible or liquefiable. So no firm and shallow bearing layer. So kunyari yung topmost soil mo, hindi siya competent layer to build a shallow foundation on. Mag-extend tayo further down by using the pile foundation. So, estimated settlement of soil exceeds tolerable limit. So, kunyari, kasi intertwined ng calculation ng settlement and bearing capacity. So, ayun nga, medyo excessive yung settlement mo na mai-induce. Pag nagtayo ka ng specific na shallow foundation dyan, we're opting for pile foundations na. And then, structural loads consist of lateral loads and or uplift forces. So, mainly pag mga railways siguro ang mga structure natin, ma-expose ang foundation natin sa lateral loads and uplift forces. Kaya we opt for this type of foundation. And excavation to construct a shallow foundation on a firm soil later are difficult and expensive. And of course, kung mas economical naman din gumamit ng pile foundation, and why not? Kaya dun tayo magli-lean towards sa foundation system na gagawin natin. So, just other classification of piles is, yun nga, yung nature of load support niya is either friction piles or end bearing. When you say friction piles, mas nagko-contribute yung capacity ng, kasi 'di ba sige, medyo crash course tayo ng pile capacity foundation. So, ang pile capacity kasi is mainly, parang summation siya ng side resistance, which is the skin friction, and the end bearing capacity. So, friction pile yung tinatawag pag mainly nagko-contribute yung side resistance niya sa bearing capacity ng piles natin. And end bearing naman, kung mas malaki ang tip resistance kesa sa frictional capacity ng pile natin. So, ang composition ng piles can be either timber, pero timber, I think, hindi na siya ganun ka-common right now. For concrete naman, yan nga, yung typical board piles natin na ginagamit. So, steel as well. Marami din tayong mga hollow steel piles na ginagamit. Lalo na kung gusto natin mag-extend ng sobrang layo din, further to the ground, as long as 30 meters, kaya din ng steel pile. And composite. Composite meaning the pile is made up of two or more two materials, different materials. So usually ang composite piles may hollow steel pile ka. Tapos sa loob nun, magi-inject ka pa ng concrete. So that's considered a composite pile. So next would be, so ayan na. So syempre, may brief background na tayo ng deep foundation. And actually, there are a lot of ways to calculate the pile capacity. So, ang dami-daming methods. Pwede tayong mag-spreadsheet, pwede tayong gumamit ng iba't ibang reference. Kasi iba't ibang reference, may different way of calculating sila. Pero, of course, minsan kung time constraint na at meron naman tayong available software, edi why not? So one of the softwares that we can use to calculate pile capacities would be AllPile. So AllPile is developed by Civil Tech. So it is a Windows-based analysis program that handles virtually all types of piles. So ayun, including steel piles, H-piles, precast, concrete piles, and all of the other piles that are mentioned here. So basically, AllPile calculates compression with settlement, uplift, lateral capacity, and group analysis altogether. So sobrang well-rounded software siya that has many outputs like yun nga, yung compression capacity, yung uplift, lateral capacity. And kung gumagamit, and ibang structures kasi, gumagamit ng group piles, pwede rin natin ma-simulate sa AllPile yun. So just a brief background as well of AllPile is, ang AllPile kasi software siya pero meron din siyang parang may reference siya na ginagamit. So sa vertical analysis, ang method na ginagamit doon, yung recommended by FHWA, AASHTO, and NAVFAC manuals. Mostly yung tatlo na yan is US codes. So sa lateral analysis naman, finite difference method to model soil structure interaction, group analysis matrix method for pile group under vertical, lateral, and moment loading, and shallow foundations. And capable din pala siya for shallow foundations. And of course, yung method naman ng shallow foundation calculation is nagbe-base doon sa principles of foundation engineering by Brahadas. So, basically, ang AllPile, pag bukas mo sa kanya, makikita mo itong interface na to. Don't worry though, mamaya papakitaan ko kayo nung run-through talaga ng software. Pero for now, muna natin to. Parang para may familiar kayo sa interface niya. So, unang-una, ito yung makikita niya sa first tab is yung pile type. So in the pile type area, you can indicate what type of pile are we analyzing. So there are numerous items to choose from. And for this project, ang ginamit namin is drilled shaft. So drilled shaft is bored pile, basically. Then dito, ini-input yung project name. Tapos dito, kung yung borehole number and pile details. Tapos you can also set the units, kung English ba or metric yung preferred units ninyo. So in the second tab would be the pile profile. So generally, i-input nyo dyan yung pile length, yung top height elevation dito. Mamaya naman makikita ninyo na din siya, parang real time din siya. Kung baguhin niyo yung values dito, parang makikita nyo na rin naman dito. Tapos, not only that, AllPile also considers uneven ground surfaces. Maglalagay ka lang ng angle dito, surface angle. And it also considers yung mga battered or inclined piles. So, kung medyo inclined ng 10 degrees yung pile ninyo, mako-consider yun na software. So, on the third would be the pile property. So, kung dito, makikita kung ano yung shape and yung size ng pile ninyo. So when you click on this, makikita nyo parang may option to select the shape. So merong square, merong circle, merong H-piles. And then meron ditong kung ano yung outside na pile. Kasi 'di ba as mentioned earlier nga, minsan meron tayong mga composite piles. So dito na-account din niya yung mga composite piles that are steel and concrete nga lang, walang timber. So ayun, for board piles, what we usually use is concrete trough. And yung inside, kung buo siyang solid pile at hindi hollow, we can opt to choose the inside is also equal to outside. Tapos meron pa ditong option to account kung hollow nga yung piles niyo. And then we also input the width or diameter of the pile here. And ayun, basically isa-set up nyo lang siya para mag-come up kayo sa pile property ninyo na gagamitin sa analysis. So for the load and group, usually ito kung ano yung exposed load sa pile ninyo, parang isa-simulate nyo siya on site. Pero usually what we use is the free head, tapos yung zero moment lang, tapos may actual load lang na support. Pero you can explore on other load conditions as well. Very flexible naman tong software na to. And then for the soil properties, ayan, nandito na, kung alala nyo kanina yung borehole data natin na sinamatize natin, tapos binigyan ng parameters, those data would come into play here. So dito natin i-input lahat ng soil subsurface profile ng soil natin dito. Tapos magpro-provide tayo ng unit weight, ng angle of friction, ng cohesion. All these, and SPT numbers. Tapos all these other na properties, software given na based dun sa method na gagamitin natin. And then aside from that, we also have yung sa advanced page. So dito, yung sa advanced page, other considerations sa capacity natin. So pwede din natin makonsider dito yung zero friction. So usually zero friction and down drag force happens pag liquefiable yung soil. So pwede natin i-tick, pwede natin i-tick yung dito, yung box to account for those conditions. Tapos, after dito, meron din tayong mga limiting values na i-input. Siyempre, kung gusto ba natin yung factor of safety natin, 2.5, or kunyari, based sa isang code, lahat ng considerations naman andito. So, basically, the output of the AllPile profile AllPile is ganito nga, may vertical analysis siya. So, makikita dito yung yung ultimate capacity na napoproduce based dun sa soil profile natin. Tapos allowable capacity din nandito kasi nag-provide din naman tayo ng factor of safety. Tapos makikita din yung settlement calculations and the likes. Tapos they can also generate graphs such as yung soil stress, side resistance, and actual force versus depth sa na-provide natin na soil data, tapos allowable capacity versus foundation depth as well. So kung paano nag-i-increase yung bearing capacity natin as we go deeper sa pundasyon natin. And also sa vertical load versus settlement din natin. So I guess we've come to the part 3 of the report. For now, I think we'll have a short break and I'll turn it over to our host kasi they have an icebreaker prepared. At para ma-recharge din tayo before we dive into a sample geotechnical report and a run-through of the AllPile software mamaya. So I think host, I turn it over to you.
Thank you very much for that, Engineer Nicole, as we will be pausing the talk for a while to give everyone a break.
So, are you guys still alive? Because we will be playing a game. Before we go deeper about pile foundations, let's have a break and tignan natin kung ano nga ba so far ang na-retain sa mga utak natin. And sino ba naman tatanggi sa mga cash prizes? May we call on the Game Master, Mr. Patrick Tolentino, to lead the activity.
What's up, everybody? Are you all still awake? React naman kayo dyan kung nandiyan pa kayo. So for our game show, we will be playing some picks and one word. Let's get into it. For the mechanics, the game will be on a first come first serve basis, which means that whoever types the answer in the chat box first gets the point, guessing the word that the pictures describe. There will be 3 rounds. Easy, with 1 point per answer. Average, the games begin. Wait lang, mag-ready lang ako. Game. For the easy round. Yan guys. One, two, three. Oh, meron na. Sino ang nauna? Ating mga arbiter. Adami tama sagot. Tama, sunflower oil, Sir Mel. Okay, close na guys. Close na. Nakita ko na yung tamang sagot. Soil. Wait lang. Antayin na yung isa kung sino nanalo. Feel ko sunflower oil nga eh. John Paul Plata gets the point. Okay, so 1 point kay John Paul Plata. Pakilagay na lang ang score natin, Mr. Arbiter Rafael J. Orque. Okay, for the next question. Clue is up. Hey, the answer has been found. Si Aliana Casas. Plasticity. Okay. So for the third question, get ready. 1, 2, 3, go. Ace. Meron na ulit. Nakita ko na. Nakita ko na yung sagot. Ba't ang bilis yung masagot? Nahirapan kami gawin to eh. Sino to? De Guzman for CEG. Same question, Jack. Meron po nagre-reklamo dito. Si Maria Christia, mahina daw net niya. The right answer was gravel. Okay. Tally ng scores, please. Thank you. For the fourth question, an easy round. Nakita po natin nung una silang tatlo. John Paul Plata with 1 point. Aliana Casas with another point. And Achilles de Guzman. Wow, Achilles. Nice. Okay. Ready na kayo for fourth question. 1, 2, 3, go. Bibilis mo ito. Mukhang puro tayo tiebreaker Sino ang naka-point? Si Mauyari Ronmark. Congratulations for another point. Hati-hati na lang kayo mamaya, guys. Okay. For the last question on easy round. 1, 2, 3, go! Joke lang. Yun na. Helmet. Ayun na, nakita ko na yung sagot. Ba't ang tatalino nyo? Nice try, Lance. Iba. Biray scores the point. Ready na yata si Lois. Okay guys, last question natin yan. So, Dito na tayo sa medium round. Equipment.
Wait lang, Patrick.
Ano yan?
May mga ano daw tayo, guest from Xavier University. Welcome daw ba sila maglaro?
Welcome po tayo dyan.
Okay, so mga taga Xavier
welcome
University, mag-react naman po tayo dyan.
React naman po. Show
Cash
your
prize
support.
po to, so lahat po pwede maglaro.
Kaya pa makahabol. One score pa lang lahat.
Okay. Okay, proceed
Okay,
na
guys.
Mr. Patrick.
Pwede. Okay, ready na ba tayo para sa second round? Let's go. 1, 2, 3, go. Ang bilis mo. Binigyan niya ata sagot to eh. Sino nagbigay ng sagot dito kay Aliana? Tama siya, guys. Casa Grande. Kasi bale, di ba reload? So, Casa kasi Tagalog. Tas Grande. Ariana Casas leading with 2 points. Ready for the second question of medium round. 1, 2, 3, go! Ano kaya yan? Clue, guys. Clue. Ace. I see the answer. Lance Ipapa with a comeback. One tap sa ulo. Lakas nyo. Gagalit pa sila sa akin ng hirap daw. Asan po ang ating tally, Mr. Rafael J. or K? 3 points na ba si Aliana? Ayan po ang ating tally. Meron na tayong first place sa ngayon. Si Aliana Casas with 3 points. O nga eh. Ayaw nga pala. 2 points pala dito. Naalala ko na. Nakalimutan ang mechanics ko. Sorry, Aspi ah. Sorry ah. Game. Technometer was the right answer. For the next question, ready na tayo. 2 points na pala dito. I'm sorry. I forgot my own rules. Okay. 1, 2, 3, go! Yan. Tower face 5,507. Time bilis. Achilles with another 2 points. See my hydrometer. Nagagalit na siya. Si Achilles yung nauna, guys. Hydrometer was the right answer. Shout out daw sa mga taga Xavier. Add nyo daw po Emmanuel de Guzman sa Facebook. Super friendly po yan. Ay, nga, mali pala ata yung spelling. Wait, we will recheck, guys. Si Aidam pala ang nauna. Guys. Wrong spelling si Achilles. Okay lang yan. May hard round pa. Shout out kay Daniela Bertuccio. Okay, ready na ba tayo? Asan po ang ating tally, Mr. Rafael J? Meron na ba tayong tally dyan? Bago tayo mag-proceed sa next round. Si Aidam ang nanalo. Tama ba? Yes. Okay guys, mukhang humahabol na sila. Next question. 1, 2, 3, go! Yan. Yes, nahirapan na kayo. I feel the medium round coming. Ayun na, nakuha na. The right answer was piezometer. By Basa Pearson. Nabasa niya na eh. Nice try, Lance. Basta yon, no? Tama. Wala eh, nabasa na ni Basa eh. Ano ang ating tally, guys? Grabe, inaabol na si Aliana. Will there be a comeback? Last 2 questions na yata for the medium round. Ready, guys? Kamay sa baba. 1, 2, 3, go! Joke lang. Round 3 na tayo, guys. Round 3 na tayo for difficult round. Ito, theories na. 3 questions lang. As far as I know. Ready na ulit. Kamay sa baba. 1. Wait lang, may nagpapa-shout out. Lawrence Reyes from SLU. Taas kamay mga SLU dyan. 3 points na dito ha. For reminder, 3 points per answer. Okay, game. Ready? 1, 2, 3, go. Ace, the answer has been found. Nice try, Kent. Nagkulang ka ng bahagya. Makatangay, Marjora. Hindi ko kita ang buo. Wait. Ay, si Marga Drew pala yun. Nice, Marga. 3 points. Habol na agad. Kaya nag-review agad guys. Pakitali po, Mr. Rafael J. Hindi, wait lang. Wait lang. Si Kevin pala yan. Kevin Celeste. From 4CEG. Yan yung ano natin eh. Si Jerks yung official score master natin. Nice, guys. So, nakatay tayo ngayon with Aliana Casas with 3 points and Kevin Celeste with a comeback from 0. Last 2 questions, guys. Who will get the point? 1, 2, 3, go! Hindi ko alam to. Totoo lang. Liquefaction. Pwede! Ito na yung clue, guys. Ano nga ba to? Di ko rin alam eh. Pass. Next question na. Ayun na. Nakita ko na yata yung tamang sagot. Yes. Grabe, walang nag-try dun ah. Di ko rin alam to eh. Stroke slow. Bigyan kong bonus to si Princess. Maganda yung idea niya. Tatlo na sila na nakatay, guys. Bale, oh my God. This is so scary. Okay, so bale, last question na tayo for the hard round. Ready na ulit. 1, 2, 3, go! Tama, medium rare. Tama ka agad, Sir Mel. Plata, getting the point. Nice try, Idam. Almost there. Tama na ba to? Wait lang ah. Tama na. Okay, meron tayong first place, guys, which is John Paul Plata. Congrats! Tapos, tatlo kayong tay sa second, third. Bale, meron tayong bonus round, guys. para sa ating tiebreaker. Bale, yung tatlong 3 points na lang ang maglalaban dito. Lahat may 600. Pwede, sponsored by Razi. Rafael Razon, the music maker. Meron pa tayong tiebreaker. Tapos sige, tiebreaker tayo guys. Para dun sa tatlong 3 points. Ready na ba kayo? Bale, since isa lang ang na-prepare naming tiebreaker, kung sino yung manalo dito, second place, tas yung dalawang matatalo, third place na sila parehas. Okay. Okay ba yun? Okay ba yun? Bale, ang magta-tiebreaker ay si Aliana Casas, Kevin Celeste, and Chua Gerard. Gerard Chua. Ba't bali-baliktad pangalan nyo? Ready na ba kayong tatlo? React kayo kung ready na kayo, guys. Para makapag-start tayo sa ating tiebreaker. Are we ready? Type 1 kung ready kayong tatlo. Okay, Aliana Casas. Isa pa. Si Gerard Chua, where are you at? Yan, okay. Bale, para sa inyong tatlo to, guys. 1, ready na. 1, 2, 3, go. Hey! Aliana Casas with a clutch. It's a prank. Hindi siya The Rock. Hindi siya The Rock, guys. Nice, Aliana. Bale, paki-DM na lang kay Rafael J. or kay yung inyong mga numbers and forward na lang sa inyo yung cash. Tapos para, bale, i-type nyo na lang mamaya dito kung na-receive nyo para hindi sabing scam kami. Congratulations sa winner! Thanks for playing. Congratulations, John Paul Plata, Aliana Casas, Gerard Chua, and Celeste Kevin. Okay, so that's it for our icebreaker. I'm taking the floor back to you guys, Janina and Jordan. Thank you so much for that.
Grabe. I love the energy. Nakakaingit naman yung mga projects.
Hindi na nila gagastusin. Pwede pa bang humabol sa Valentine's?
Pang Shopee ko na sana yun. Kung pwede lang sana sumali. Pero balita ko, a little birdie told me.
Oo, ang mga 4CEB dyan na hindi naman nakasali. Tsaka yung mga taga Xavier University ulit, may game pa tayo mamaya.
May pag-game si Miss Engineer.
Oo, sa Gcash din daw ang prize. Kaya galingan natin humabol. Dapat di nakasali yung mga nanalo eh.
Congratulations and thank you to everyone who participated. Alright, we know you guys are very excited to use your cash prizes. Pero bago yan, may we first welcome back Engineer Nicole back on stage to continue the second part of her talk about Pile Foundation.
So, hello guys. So, I'm assuming naman everyone felt recharged dahil sa icebreaker na yun. And props to the host and sa game master natin si Patrick for making it lively and interactive for everyone. So, teka, i-share ko lang yung screen. I-share ko lang yung screen ko so that we can proceed to our discussion. Ayan. So, can everyone see my screen right now? So, ayan. So, before we proceed kasi 'di ba, ang main focus nga natin dito is knowing and trying to figure out how the AllPile software works. Pero, paano nga natin ita-translate yung ginagamit natin sa software and yung output niya sa typical sample geotech report na gagawin natin. So, bago yon, may pag-game din ako for everyone. So, I didn't know actually na yung commercial break ng mga organizers natin ay about games din. And nag-prepare din ako ngayon so that the organizers can also join sa game. So, 2 questions lang siya. Tapos, humble amount lang. Huwag kayong mag-expect. Pero, I think enough naman na yun para ma-break lang din yung ice natin. So, siguro kung sino din yung nanalo kanina, wag na kayo sumali, wag na kayong gahaman. Give chance to others na. So, basically, ang ano lang nito, ang mechanics lang ng game na to is magfa-flash ako ng magfa-flash ako ng question sa screen. Tapos, the first one to type yung certain word na yun is siya yung may chance na mag-speak out para sabihin yung answer. So, hopefully naka-turn on yung video and para marinig ko rin kayo kung anong boses ninyo, kung anong tsura ninyo, gano'n. Para may feel din ako, para at least man lang medyo personally or face-to-face yung interaction natin. So, ayun, 2 questions lang to. So, I'll proceed now with the first question. So, basically, yung mga questions ko naman, mga geotechnical trivias lang to. So, I believe na kung nakikinig talaga kayo ng geotech, masasagot niya to for sure. So, the first question, ready na ba kayo? Can I get any reactions? Man lang, heart, or anything na ready na kayo maglaro? Alright. So, game. So, first question is, a famous tourist attraction which is actually a geotechnical engineering failure. So, merong very, very popular na tourist attraction na, ayun nga, kala natin maganda, pero underlying problem pala niya, may geotechnical engineering din siya. So, I would be needing yun lang, yung name ng structure na yun, and hopefully kung saan din siya located. So, the first one to type famous sa chat box would get the answer. So please type in na kung alam niyo. Teka, paano ba to? Hindi ko makita kung sino yung first na nag-chat. How do I? Or pwedeng pa-help na lang mga...
Kami na lang po magsabi po ng name.
Ay, teka, hindi ko kasi makita yung chat box eh. Teka.
I-ano po ba namin? I-announce pa namin kung sino?
Oh, i-announce nyo na lang sa akin kung sino yung first.
Feeling ko ako yung nauna. Charot.
Honesty policy tayo, girl. Charot.
Si
Pero,
Emmanuel Patrick Jeremiah.
Hi, Emmanuel. Hello.
Mag-on cam daw po ba?
Oo.
On cam daw
possible.
po, Mr. Emmanuel.
Hello po.
Hello. So, ayun. So, you are given a chance to answer this trivia, a famous tourist attraction which is actually a geotechnical engineering failure. So, ano sa tingin mo
Leaning Tower of Pisa po.
Ayun. Saan siya located?
Pisa, Italy.
Ayun. So, ayun. He's actually right. So, teka. Ayan, fail. So, yun nga, Leaning Tower of Pisa siya. So, technically, syempre, napaka-iconic niya being, leaning towards siya, pababa. Pero in actual, ang dami niyang foundation and settlement problems pala na na-overlook na rin ng mga previous engineers na gumawa nito. However, ni-retain na lang nila na ganyan yung scheme ng structure at na-stabilize naman siya over time. So, I'm guessing na na-resolve na din yung mga settlement issues plus stabilize na lang nila para inclined pa rin yung ano niya. So, ayun. Thank you, Emmanuel. Gusto mo ba mag-shoutout? May shoutout ka ba or something?
Hindi na po. Okay lang po.
Okay lang. Sige. So, please,
Sige
sa
po.
host siguro na pakuha na lang yung GCash number niya and relay it to me na lang. As well as sa next na mananalo natin.
Go, Patrick.
So for the last trivia. So ready na ba kayo? Can I have more reactions, please? If ready na kayo. Alright. So I guess kung maaga kayo at pumasok sa meeting na to, you probably heard the name and kung anong term to. So, syempre, sino ang father of geotechnical engineering? So the first one to type, father, would be given a chance. So host, kung meron na.
Meron na pong nauna. Si
Okay.
Edward Gutierrez po.
Oh, hi, Edward.
Pa-on cam na lang po.
Yes.
Hello po.
Hello. So, ayun. So, sino sa tingin mo ang tatay ng geotechnical engineering?
Si Carl von der Sagi po.
Yeah, that is correct. So, I think kahit sino naman ata, on the onset pa lang ata nagsimula ang soil mechanics nyo. You probably heard the name, Carl von der Sagi. Thank you for saying the whole name. Sorry na nakaligtaan ko yung sa gitna. Pero ayun nga, Carl Tersagi is very famous in the geotechnical engineering. Specialization is lalo na sa contributions niya ng maraming equations sa bearing capacity, settlements, and all other equations out there na ginagamit natin ngayon. So, moving forward, so I think recharge naman na kayo sa numerous games na nagawa natin. So let's proceed na sa topic natin. So bago ko ipakita sa inyo kung paano tayo, yung talagang, ano to? Yung on-hand na gagawin natin sa AllPile, papakita ko lang sa inyo kung ano yung typical geotechnical outline ng typical geotechnical report na usually ginagawa ng mga geotech engineers. So una, meron tayong soil investigation. Yun nga, parang kumukuha tayo ng soil data through borehole drilling, test pit sampling, mga lab testings and the like. Tapos, after natin makuha yung data na yon, syempre, gagawa tayo ng idealized subsurface condition na para ma-summarize lang natin lahat ng findings natin sa nakuha natin sa soil investigation. Tapos, from the summarized na subsurface conditions, makikita na natin doon since makaka-derive na tayo ng parameters na gagamitin natin sa kung ano-ano mang analysis natin na gagawin. Makaka-come up na tayo ng foundation analysis, ng slope stability analysis, potential geohazards, excavation considerations, if any, and other recommendations na relevant dun sa study natin. Then afterwards, we will combine all these data to come up with our geotechnical report. So, sorry, mali. Hindi pa sneak peek. Ayan. So, ito na lang muna. So, please bear with me. I'll just transition this. So, ayan. I think makikita niyo naman, no, yung... So, meron tayo ditong geotechnical evaluation report na I prepared for Project X in Bocaue, Bulacan. So usually ito yung first page ng report na ginagawa natin, also including the date that we drafted. So the basic outline of a geotechnical report, aside yung sa basic outline na pinakita ko sa inyo, will be consisting of introduction, objectives, geotechnical investigation program, site conditions na makikita nyo later, and analysis and recommendations. And then, of course, may conclusion tayo, mga closing remarks lang din. So there. So, bale, ang client natin, binigyan tayo ng boreholes na para i-assess ang isang site sa Bocaue, Bulacan. So, I'll just show you the borehole na binigay sa akin. I apologize for the last lackluster presentation kasi na-realize ko na wala palang borehole talaga na input ang binigay sa akin. Mostly handwritten siya, so field log siya. Pero actually hindi siya field logs. Talagang tinamad lang silang i-computerize pero nag-lab test na dito. So ito ang usual final borehole log and summary of test results. So we have yung depth ng drilling natin, sample number kasi nga nagre-retrieve tayo ng samples, recovery samples for coring if meron man tayong ginawang coring, log symbol, I think ito na yung mga gradient kung ano bang soil type siya. Pero in this case, since handwritten lang siya, it was left blank. So apologies for that. And yung classification nilalagay din natin, which is yung USCS na commonly na ginagamit natin. So other than that, we also provide description kung anong nakita ni driller sa site. So SPT and number of blows. Ayun nga yung number of blows na usually yun yung ginagamit natin para mag-derive ng cohesion and angle of friction kung sandy or clayey ba yung soils natin. And then of course, yung natural moisture content andoon din, as well as yung Atterberg limit and yung results ng sieve analysis natin. It's also divided yung 4% ay yung ito yung diameters ata ng sieve number, sorry. So yung diameters niya iba pa yon. So ayun, ito yung typical na makikita niya sa isang borehole. They should also have, so actually pinapakita ko sa inyo mga bad example ng boreholes. I'm so sorry. pero yun nga, dapat sa ibang borehole indicated din yung water level natin para makita kung anong depth yung groundwater natin na na-encounter nila while drilling. Date gauge kung kailan nila nilagay yung groundwater monitoring doon. Ground elevation na na-survey nila para makita lang kung ano yung elevation zero natin sa borehole drilling, as well as yung weather para makita lang kung fine, sunny, or rainy kasi it also contributes sa saturation and moisture content sa soil natin. So we also indicate the project name, of course, location, and borehole number, and date drilled kung yung duration ng drilling niya. So ayun, sa example sa depth number 1, we have, ang nakuha nilang sample doon is SC, which is clay sand siya. So sandy material siya. Light brown clay sand with some gravel size sandstone. And they deemed it as loose kasi ang end value niya, I'm so sorry malabo, i-dictate ko na lang, 8 yung nakuha niyang number of blows. So indicative siya na loose materials yung nasa upper layer natin. And then of course, since gumawa na rin sila ng sarili nilang lab testing, indicated na rin yung moisture content, Atterberg limit, sieve analysis na nakuha nila. And these procedures goes on until the termination of the borehole. So this borehole extends up to 35.87 meters. So ayan yung isang field borehole na ginamit, as well as other than that pala sa boreholes na yan, nag-test pit din yung client natin. So, andito rin yung mga test pit details, pero hindi ko na ito masyadong i-go over. Bibigay ko na lang sa inyo yung samples na ganito for your future reference. But mainly, ang focus talaga natin ngayon would be the borehole data. So, other than sa borehole 2 natin, may isa pa tayong provided na borehole, which is ito din. Invite. Ayan, so borehole number 1. And the same goes lang din. Indicated dyan lahat ng details. And the borehole extended up to a depth of, I'm assuming nasa 38 din, medyo malabo dito. So ayun nga. So with that said, yun na yung details ng borehole data natin. So balik ulit tayo sa geotechnical report natin. So given na tayo ng borehole data from client, so kailangan na natin mag-draft ng geotechnical report. So as mentioned earlier, may outline tayong fina-follow sa report. So unang-una, which is yung introduction. So ito lang, parang konting write-up about that. This report presents the results of the soil investigation as well as the results of the geotechnical analysis and corresponding recommendations for the study area of Project X in Bulacan, Bukawi. So usually sa introduction, papakita ninyo yung location map, tapos i-indicate nyo doon kung nasaan yung project site natin. Tapos other than that, syempre objectives, maglalagay nga tayo din ng objectives para parang at the end of the report, ito yung mga sasagutin natin at mapoprovide natin sa client. So ang objective natin dito, assess the geotechnical conditions, derive the parameters, identify the susceptibility of the project, and recommendations na relevant din sa study natin. So the third part would be the geotechnical investigation. So I've mentioned earlier nga na yung geotechnical investigation na provide sa atin is 2 boreholes plus all other test pits that will be used for civil works matters later on. So in this part also, we indicate the borehole number, dapat borehole 1 to and borehole 2, tapos yung depth of drilling, water level if indicated, and yung date of drilling. So parang sinasummarize lang natin yung mga na-retrieve na boreholes, as well as we also provide the location maps kung saan na-drill and saan na-excavate yung mga test pits. So ayan, dito, and another one, kasi masyadong malawak, so they just parted it para mas visible siya sa magbabasa ng report. So on the next section, ayan na yung site conditions niya. So I've mentioned earlier nga that we have 2 boreholes that we need to idealize. So yung first one, yung idealized subsurface condition at Toll Plaza. So yung ginawa natin kanina, syempre yung borehole kasi napakadami niyang data. Parang as geotechnical engineers, we need to simplify and para maintindihan din ng reader ng report natin. It is our job to simplify and make them understand this report easier. Kahit na with minimal knowledge lang, maiintindihan nila nito. Siyempre kung papakitaan mo ng ganon, ma-overwhelm din sila. So ayun, dapat na gawin natin siyang concise and mas convenient for them na maintindihan. So ayun, in-idealized subsurface condition at the borehole. So ayun nga kanina, indicative siya yung sa una na loose yung materials niya sa taas. Tapos in-indicate natin dito yung end values. Tapos may corresponding relative density din siya. Ito yung nakita din natin sa description. So ayun, sinasummarize lang siya. Usually, parang ginugroup natin yung idealized na dapat same sila ng soil type. So usually group together na ang sands, tapos group together din ang clays. Tapos kunyari may in-between sand layer ka, tapos clay, tapos sand ulit. Usually hindi pinagsasama yung sand na para maano. Parang iniisa-isa talaga siya. Basta yun yung golden rule pag i-summarize mo lang siya or i-compress mo siya pag same soil type siya. So ayun, so ang nangyari, meron tayong madaming layers pa sa idealized portion. Tapos same goes doon sa other borehole natin, sinummarize na natin siya, tapos subdivided na siya into 6 na layers. So comprising ng clay sands, low plasticity clays, low plasticity clays and silts. Tapos dito may mixture ka ng low plasticity clays and high plasticity na silts. And then underlying noon, meron na tayong very stiff to hard layers ng clays and silts. So usually, after idealizing it, syempre medyo mag-provide din tayo ng write-up para ma-summarize mo lang. Kasi ito parang per borehole tayo nagsa-subsurface idealization. So parang mag-provide din tayo ng write-up yung general subsurface condition ng site. So ayun. So for the test pits as well, we also summarized the data and provided some write-ups kung ano lang yung brief description nila. I think yung test pits mas makakatulong to to find out kung expansive yung clays, kung ano yung CBR value. Kasi may certain CBR value na dapat sa soil para makatayo ka ng mga roads and other civil work structures. So ayun, significant tong data na to if gagawa tayo ng ganon. So ayun, summary of test pits. And we also indicate the project site seismicity. Parang papakita natin dito sa site kung ano yung nearest na fault line. So in our project site, ang major fault line kasi usually is the West Valley Fault, which extends up to the north hanggang sa south sa Laguna. Yung sa project site na to, 27 kilometers away naman sa project site. So medyo hindi naman insignificant, pero lower impact niya sa magiging analysis natin. So in connection with the seismicity, syempre, if there is earthquake and there are loose soil materials, may potential na liquefiable yung area. So we also assess the liquefaction susceptibility of our project site. This is actually readily available in PHIVOLCS. Kasi minsan hindi na tayo nag-i-in-depth na liquefaction study sa isang site. So, gagamit lang tayo ng mga risk maps. Ayun nga, thankfully, ang PHIVOLCS nagpro-provide din nito. So, you might want to check them out kasi per region naman nagpo-provide sila and meron din for the whole map of the Philippines para sa isang general risk assessment sa liquefaction. So, based nga dito, with the traces of loose sand and medium dense din that we found in the borehole, susceptible nga yung area sa liquefaction. And consistent siya doon sa provided ni PHIVOLCS na map. So, ayun nga. Then we go over sa analysis and recommendations. Since nakita na natin yung borehole data, na-summarize na natin, it's now time for us geotechnical engineers to interpret our knowledge based on the soil investigation data that were provided to us. So, unang-una, I think the requirement for this project is yung tall area is naka-shallow foundation lang siya. So sa shallow foundation, syempre tersagi bearing capacity ang usually na ginagamit natin dito. I think the base equation was really developed by Tersagi, pero yung mga factors sa shape, sa unit weight, sa cohesion, and sa shape factors and all other factors, I think yun na yung namo-modify ng iba pa nating geotech engineers as they go along and have a deeper understanding of the topic. Pero ang base talaga is kay Carl Tersagi. So ayun, it was deemed na yung allowable capacity niya is nagre-range lang sa 55 kPa and 60 kPa. Understandable to kasi nga based sa borehole natin, di ba, parang loose sand materials yung sa taas. So we expect na hindi ganong kataas ang bearing capacity niya sa upper layers natin. And even if you extend further down, I think hindi pa siya yung talagang potential enough na mag-carry ng isang malaking structure kasi hanggang 65 kPa lang din ang capacity niya at 3 meters. So, eto embankment and pavement design. Minsan kasi ang clients natin gusto lang nila ng some guidelines sa pavement design, and if I'm not mistaken, ito galing to sa DPWH. And yung presence of expansive soils nga, makikita siya is very dependent sa plasticity index na nakukuha natin based sa mga lab test results. So, ayun nga, meron dito na makikita sa test pits natin, medyo may medium to low na potential lang siya. Pero at some sites, may very high risk siya ng expansive clays. So, ayun, we go now to the deep foundation side. So, yung deep foundation kasi, ni-required siya dun sa exit ramp ng buong project site natin. So, based doon kanina sa borehole, balik ko dito. So, ayun nga, meron tayong, so yung idealized subsurface na condition natin sa exit ramp, gagamitin na natin siya para mag-come up ng parameters dito. Ayan. So, you might be wondering, paano nag-come up? Kasi di ba range yung kanina na pinakita ko sa inyo na N values. So usually, sa range na yun, mag-average lang tayo. More often than not, mag-average tayo. Pero minsan kung masyadong mataas ang ranges natin, yung lower limit yung ina-adapt natin para makakuha ng property. So, bali, from the idealized subsurface condition, i-boil down pa natin siya sa yung talagang gagamitin nating end value for design. Tapos, for end value for end value, meron siyang corresponding unit weight, cohesion, and angle of friction na nagde-depend sa soil type niya. So, I think meron ako nun dito. Ang pinaka-basic na ginagamit for correlations, sorry, may kamay pa. Ang pinaka-basic na ginagamit na correlations ay galing sa Bowles. I think everyone is familiar naman with Joseph Bowles. Tapos parang madami siyang test na ginawa. Tapos he also came up with the correlation relating the end value and the soil type of a certain soil to its unit weight, to its undrained strength, which is yun nga yung cohesion, to its unit weight, and to its angle of friction. So bali yung undrained strength applies only to cohesive soils. Alam naman natin pag cohesive soils, wala silang friction angle. And likewise, pag yung soil natin is sandy, wala rin silang cohesion. So, ito lang I think I'll provide na lang this sa inyo para may brief background lang kayo on how the correlation works. So, ayun nga, based nga sa end value niya, may corresponding tayong angle of friction for sandy soils, cohesion value for clay soils, and unit weight for both soil types. So, dahil doon, nag-come up tayo per layer ng unit weight niya, ng cohesion niya, since sandy nga siya, 0 nga siya. Tapos, angle of friction corresponding dun sa end value niya. So, you might be wondering ano tong KH. Ito yung modulus of subgrade reaction. I think for our discussion, hindi ko na din to masyadong i-dive into kasi for structural engineers to. Para lang makita yung spring action sa pile foundation. It's for their analysis, for another structural analysis ata yun. Pero provide natin to for our structural engineers. So, ayun. So, ito yung pile capacity analysis results natin. So, si client, nag-provide na siya ng length and diameter na gagamitin sa nagagamitin na foundation. So, let me just go ahead with the AllPile. Yan. So, ito yung AllPile in its raw glory. Ito. So, bale, ang reference muna natin dito is yung exit ramp na board pile na 1,000 yung diameter. So, given nga na board pile siya, so it is considered a drilled shaft. That's why dito sa pile type, drilled shaft ang pinili natin with diameter greater than 24 inches or 61 centimeters or roughly 610 mm. Ayun. So for project title, syempre project X southbound ramp. And then project title number 2, yun na yung details ng boreholes natin. So board pile 1,000 at exit ramp. So units of measurement na ginamit natin dito ay metric. So for the pile profile, it was indicated in the drawings that we should use a length of 32 meters. So it's also reflected here for consistency. Ang top height niya is 0 since wala din siyang indicated na exposed length siya. Pero pwede din natin yun ma-modify if ever man may exposed length kayo. So, ayan, ma-indicate nyo naman dyan. And surface angle, 0 din yung indicated kasi parang even naman yung ground sa site. Pero if you wish to edit it, pwede naman siya. Ayan. I apologize, kala ko interactive to. I think yung sa battered files lang siya sana. Oh my God, hindi rin pala. Ayun. Pero ayun nga, for considering inclined piles and uneven surface, pwede nyo din i-modify ito. Yan. Ayun pala, sorry. Ayan, nakikita niyo naman yung orientation niya kung if ever man uneven yung ground surface. Tapos yung battered pile, ayan, nakikita niyo din. Yun. So for presentation purposes and for consistency na din nung sa report natin, I'll leave everything to 0 muna. And just add the pile length that was indicated in the report as well. So yung pile property niya, we've established na board pile nga siya. So it's a concrete na rough na pile that is circle in shape. So sa shape natin, circle nga, tapos concrete rough siya. Ang concrete smooth, you might be asking siguro, hala, bakit hindi concrete smooth? Kasi ang concrete smooth, kasi di ba pag board piles, parang i-excavate, hindi naman excavate, gagawa kayo ng cylindrical hole, pababa, tapos medyo rough, parang nakaka-contribute din kasi yung friction ng pile, yung interaction niya sa surrounding soil niya. So kaya concrete rough siya. We only use concrete smooth kung driven pile ito na concrete yung materials. Kasi nga parang i-drive down mo lang siya up to your desired depth. Kaya dun mo lang siya i-set as concrete smooth. So for the inside equals outside, syempre buong board pile naman yung gamit natin. Di naman siya hollow. And then dito, leave everything. Yung iba usually hindi naman na ginagamit. Pero eto nga, itong inside materials in total area, I think this applies to hollow. To hollow piles. So, yung dito, we also indicate yung diameter ng pile natin, which is 1,000 mm nga. So, translating to cm, it's 100. Ang hindi lang medyo okay sa ano na to is, kailangan mong i-click itong part na to para mag-calculate siya ng area. Tingnan nyo, kung iibahin ko siya, hindi siya automatic na magka-calculate. Parang kailangan nyo siyang i-click para i-process niya yung other properties ng file na to. So, ayan, let me just get this back. Ayan. So, once we've established na yung file properties na gagamitin natin, dito na tayo sa load group. So, usually, yung load group na ginagamit natin is tong free head lang, tapos magpo-provide lang tayo ng actual na load. Yung actual load usually comes from the structural engineers, kung ano yung na-solve nila with their STAAD results. Tapos parang ipapass, syempre yung load na yun ipapasa sa foundation. So yun yung provide nilang load sa atin. So in this case, parang actual load lang na 7,860. Sige, I forgot bakit ito. Pero I think random number lang siya, but you'll see later on. Tapos aside from that, kasi I've mentioned nga earlier na capable din naman si AllPile ng group pile analysis. Ayun din, mamomodify nyo din siya dito. And as well as foundation tower, pwede din siya dito. Personally, wala pa akong experience between these two. So, focus muna tayo sa single pile capacity. I think this would be the most relevant din na topic na para sa inyo for now. So, after we've established the type, the pile, profile, the properties, and the load and group, we now proceed yung sa soil properties niya. So, kanina, di ba nga gumawa na tayo ng geotechnical parameters na gagamitin natin. Now, ilalagay natin yung soil profile na yon dito sa software natin para siya na yung mag-calculate ng capacity, ng compression capacity ng itatayo nating pile. So, ayun, i-input mo lang dito yung elevation. Usually, ang ini-input dito yung top elevation. That's why it starts at 0. Then 2, 3, 7.5, 10.5, 22.5. And what this means pala, yung greater than 22.5, since parang base sa borehole natin is yung depth lower than that. Ganun, yun na yung ina-assume niyang, yun na yung ina-assume niyang condition up until kung ano mang length tayo mag-extend. So, ayun. So, ayun, we've also established na sand sandy siya sa taas, tapos puro clay and silt sa baba. Tapos dito yung unit weight. So ang ini-input pala natin dito is effective unit weight. Although hindi indicated sa borehole data natin yung water table level ng drilling natin or kung sa site natin, usually in practice, we assume na saturated yung soil. That's why we indicate na ang water table natin dito ay 0. At ang foundation na gagawin natin ay surrounded by saturated soil. I think it's also to account for more conservatism sa analysis natin. So, kaya yun yung naging practice na din. That's why you might be wondering, hala, bakit 8.2 yun? Ayan kasi yung effective unit weight na ginagamit natin. So, ayun, 8.2, 10.2 since medyo hard clay siya. Ayan, and it follows naman. Tapos for the fee, ang nag-provide lang tayo ng angle of friction is yung sa topmost layer na gravel. And yung cohesion, ayan. And yun nga, yung properties na to based doon sa correlations na provided ni Bowles sa book niya. And then for these items, for K, for E50 and type, yung software generated na to. So usually hindi natin to hinahawakan. And yung SPTN value, yung NSPTN value, yun din yung reflected sa idealized natin. So other than that, ayun nga sa advanced page kung ano pang other considerations. So kung may liquefiable ba? Actually, di ba dinim natin siya na liquefiable? Pero kasi kung makikita nyo, yung N value na na-adapt natin is 19 na. Relatively medium din siya. So, at medyo matigas na din siya. Considering na medyo matigas na din siya. So, hindi na natin in-adapt yung zero friction dito. Pero in the instance na kunyari, yung sand layer natin, loose yung ano niya, loose yung density niya. Ititik natin itong zero friction na to. Tapos i-indicate natin from what depth to what nag-e-extend yung zero friction na yun. So, ayun. Same with the down drag force. And ito nga, ito lang yung mga list ng factors of safety adapted for downward, for the side, for the tip, FS for uplift, load factors, and limits, and the like. Tapos yung load settlement relation, basic. Ito basic yung method. By default, basic talaga. Tapos, ayun nga. So, from there, pag na-input nyo na yung lahat ng considerations na yun, pag clinic nyo tong vertical analysis. Yan. Oops, sorry. Didn't appear here. Yan. So, makikita nyo na yung summary output ni AllPile. Sorry. Hindi na din siya na-zoom. Ay, ito. Ayan. So, makikita nyo dito yung lahat ng details na in-input natin. So, yung soil depth, yung ano niya, properties per depth. Tapos, makikita din dito yung vertical capacity. So, yung weight above ground or side resistance. Ay, yun. It also computes separately the side resistance and the tip resistance of the pile. To come up also with the total ultimate capacity and the total allowable capacity. So, yun nga, yung allowable, na-derive lang naman siya pag dinivide mo by the factor of safety, yung ultimate. And same goes with the uplift capacity of it. So, meron kang ultimate, meron kang allowed. Tapos, kung mapapansin nyo kanina, di ba parang nag-provide tayo ng actual load na 7,000 plus. Dito, nag-reflect siya na pag ganun yung actual capacity na carried over ng structure natin sa ground, not allowed siya kasi mas mataas yung actual force na nangyayari sa pile kaysa sa capacity niya to resist it. Parang ganun. Ay, yung actual force pala, sorry. Na kaysa dun sa capacity ng pile niya to resist it. So, ayun lang. And it also calculates the settlement nga na using yung basic na method. Indicated din naman dito. So, ayun. Eh, syempre, since excessive nga yung actual load na in-indicate natin kanina, eh, sobrang taas din ng settlement na na-induce sa pile natin. So, ayun, basically, that's it for the AllPile. So, yung makukuha natin nga na results dito ay i-input lang natin sa report natin. Sorry. I'll also show you the data na ano niya. So, ito yung soil stress and side resistance and axial force. So, nag-graph din siya per depth ng vertical stress, ng side resistance, and yung axial force na ano. Other than that, we also have the load settlement graph. So, kung ganito yung load na nai-induce, ganito yung corresponding settlement na mangyayari sa pile natin. Other than that, yung pile capacity and depth, andito din. So, makikita ninyo na syempre, as you go deeper sa foundation natin, tataas din. It makes sense naman talaga na as you go deeper, tumataas lalo yung capacity natin. Tapos, if you're very mindful of the format ng graph nila, I think it also shows the raw data para kayo na mismo yung mag-graph sa Excel kung ano mang presentation. So, ipakita ko na lang siguro dito yung sa capacity. Yan. Sorry. Ayan. So, ito yung raw data na mapapakita niya kung if you would opt to import your output sa Excel, tapos kayo na mag-further modify kung paano nyo i-represent. So, it also shows the length, the bearing capacity at the tip, the side resistance, and kung in-add mo to, it should amount dun sa ultimate capacity, downward capacity, so bali axial. Tapos other than that, meron din siya yung sa uplift force naman. So ayun, medyo mahaba lang siya, ganun. Pero very straightforward naman to pag na-import niya na to Excel. So, ayun, other than the vertical analysis, it also shows yung lateral load capacity. Same thing, ganun din naman yung output. Ayun, ganun din naman yung output. Pero medyo hindi recommended ang lateral analysis sa AllPile. I'm not sure of the reason why, pero I think there are better ways to calculate the lateral capacity ng piles natin. Pero kung kung ang after nyo lang ay yung compression, uplift, I think AllPile would be the most straightforward software that you can use. Also be mindful na in using softwares, garbage in, garbage out. So that's why in-explain ko thoroughly sa inyo kung paano tayo nag-come up ng parameters para ma-justify natin kung ano yung pinag-i-input natin sa software, and para lang mas ma-explain din natin siya sa client natin na ganitong procedure yung ginawa natin. So ayun lang, please. Although kahit napaka-convenient kasi gumamit ng softwares, to be honest, as in it saves you a lot of time, a lot of effort. Pero kung yung mga parameters and data niyo naman doon na pinaglalagay walang justification, walang basis, wala din namang, hindi rin naman significant yung makukuha natin na results from there. So ayun, having that said, and having shown you kung ano yung capability ng AllPile software sa pag-calculate ng pile capacity, ilalagay na natin dito sa report natin yung compression capacity na nasolve natin. So it was 3,500 for 55 kilonewtons for the exit ramp of the diameter 1,000. And yung sa isang diameter naman, since bigger siya and longer, it's expected na mas mataas yung compression niya. So, ang nakuha nating results is 8,300 kilonewtons. Tapos, usually, pag nagpa-pile testing tayo sa report, nag-i-indicate din tayo ng grounds for pile testing. Kasi habang nag-i-install tayo nagko-construct and nag-i-install tayo ng piles on site, there are also required pile tests na non-destructive test naman siya para makita natin yung, kunyari yung na-solve nating capacity. Gaano siya, ano yung discrepancy niya sa actual na capacity niya sa site. Kaya gumagawa tayo ng mga static load test or yung pile integrity test na sinasabi nila, which is, yun nga, yung pile integrity non-destructive test din siya to check lang. Parang may hammer na iaano sa pile. Tapos, parang mga waves and everything else yung output niya. Pero mainly, ang gusto niyang ipakita na hindi hollow yung nagawa. Walang walang ampaw yung na-construct na piles natin. So, ayun. Then, seismic design considerations. I think, parang na-correlate ang lahat ng factors na to sa distance ng seismic fault line natin sa study area. So, meron tayong, I think, nasa NSCP naman to, if you recall sa mga earthquake natin. So, this mainly helps our structural engineers din para sa earthquake assessment or structural analysis man kung anong structure na gagawin dito. And yun nga, conclusion na geotechnical evaluation recommendations were based on the results of ganito, ganyan. And then yung date and yung signing na na engineer dito, it's also indicated sa report. Tapos yung yung designation ninyo and yung PRC number as well. Kasi minsan sine-check din nila kung legitimate yung syempre, to come up with this report, dapat credible ka din na meron kang mapapakitang credentials so that you're fit to draft this report. So, I guess that's it for the geotechnical report. Sorry, it became very kind of technical and I think medyo nakaka-overwhelm nga siya sundan, lalo na virtually to. But don't worry, I'll provide you all these para ma-study nyo siya further, especially kung very related din siya sa sa magiging thesis ninyo sometimes. So, ayun nga. So, having that said, so nakita niyo na kung paano yung isang typical na geotechnical report, and you might be wondering, asking yourself or wondering na, baka ganito lang yung buhay natin pag geotechnical engineer. No, it doesn't revolve on the foundation alone and drafting those kind of typical reports. Just a brief overview of what I've done then as a geotechnical career in my career journey. I've been involved with the PNR-NSCR. If you're familiar, this is the Philippine National Railway, the North-South Commuter Rail that extends from Tutuban to Bulacan. So, na-involve ako doon and we evaluated 485 boreholes. So, ayun nga. So, pag geotech ka, please expect na you would be evaluating very numerous boreholes. Kasi the more boreholes that you evaluate on-site, the more na mas confident ka na ganito talaga yung site conditions on-site. Parang mas may basis ka na bakit ganito, na bakit ganyan. So, for that project, there were 485 drilled boreholes para sa buong alignment ng railway na yun. Tapos, of course, we recommended shallow and deep foundation sa along the alignment. Yung shallow doon sa mga stations, I think, kung tama recollection ko, and deep foundation doon sa mga area na swamp areas na. So, hindi na kaya ng shallow foundation alone. So, since swampy areas nga yung ibang dinaanan, we also encountered some settlement and liquefaction analysis then to assess the susceptibility of the site to those hazards. And then similarly, I've also been involved in MRT7. Ganun din siya. Rail system din siya that extends from North Ave to SJDM. Then nag-shallow deep foundation kami and nag-liquefaction analysis din kami. Tapos 249 boreholes yung nagawa doon sa ano na yun, sa project na yun. So other than that, one of the most memorable siguro, kasi nahirapan ako dito. Nahirapan ako na may slope monitoring kaming ginawa na industrial facility sa isang industrial facility. So bali nag-slope monitoring kami kasi high risk yung slope na yun. So imagine niyo ito yung slope. Tapos sa toe ng slope na yan, may mga gumagawa. So may mga I forgot yung pero may mga works na gagawin sa baba ng slopes. So since high risk na tong slopes na to and wala siyang masyadong remediations, pero kailangan na nilang gawin yung works na yon sa to. Kailangan nilang i-monitor yung behavior ng slopes na to. Kung impending na ba siya mag-fail, kung nag-slight movements ba siya, para kung ma-deem na medyo nag-move yung slope na yon, magsa-stop work yung sa baba. So bali, mas na-concern kami dito sa safety and kung magpro-proceed yung mga workers na magtrabaho dun sa toe ng slope na yun. So ayun, mostly instrumentation siya na may data logger, tilt meters, sensors, rain gauge, alarm. Tapos kung yun nga, kung may slight tilts or movements dun sa slope na yun, may alarm na magre-ring para ma-alarm din yung mga workers na evacuate muna tayo for the meantime hanggang maging stabilized natin. So, sorry. Sorry, medyo may Tapos, another project that I've also been involved in is yung post-earthquake assessment kasi may sumabog, may phreatic eruption din sa isang sa isang industrial facility. So phreatic eruption is earthquake. I think mga magma syempre where there is opening or there is path, susunod yung mga water doon or yung mga magma flows. Tapos parang in some instance sobrang ewan ko dahil sa magma tapos nag-earthquake nga. So nainit ng magma yung underground heat source. So nag-erupt siya sa isang slope sa facility na yun. Ito yung naging itsura niya after. Tapos basta sobrang naging devastated yung slope. Yung slope na yun parang kailangan nila. So from there, kailangan namin agad na mag-remediate ng soil. Kasi kailangan na nga siyang, may gagawin din doon. Saka para baka maging impending failure uli siya. So nag-provide kami ng remediation measures. Nag-stability analysis muna kami ng current condition niya. Kasi may mga LiDAR datas din. So nag-establish muna kami ng current condition niya na stability. Then afterwards, yung recommended din namin na remediation measures. So for this area, since malawak naman siya, benching ang nagawa namin na slope remediation measures. That's why makikita ninyo may mga berms siya. Tapos yung slope niya napakalaki rate para hindi din siya mag-topple off. So after a few years nung natanggap yung design, naging ganito yung itsura niya. So ayun nga, in-apply nila yung berms and some drainage provisions as well para may daloy yung tubig. And other than that, we also do geotechnical modeling and finite element analysis on the overall behavior of piles. So itong project na to, sa Singapore siya, tapos sa may wharf area siya. Madaming contiguous piles kasi siya. So as you can see here. Tapos madaming mga mabibigat yung loads na nasa taas ng pile structures na to. So we needed a geotechnical model and finite element analysis para makita namin yung behavior ng piles. Kung okay lang ba siya na ganun yung mga loads na nai-induce sa kanya or not. And actually, I think yun na yung end ng presentation ko. Pero one more activity before we conclude. I guess with the 1 hour or more na discussion natin. Hopefully, I've impacted you and shed light to what geotechnical engineering is. And I just want to see kung ilan people. I think please go to the Mentimeter. And sorry. Sorry. Let me just fix it muna. Ayaw mag-next slide. Ayan. So, I guess na somehow sana naka-impact ako positively sa pagiging sa journey nyo with Geotech. So, I would just like a show of wow. Show lang ng I mean, number lang na after everything that I've said, yung lahat ng na-explain ko, just some background. So, to geotech or not to geotech ba ang field ninyo in the future? So, ayun. Please take your time in answering that. So far, so good. Hopefully, hindi niyo ako binabola sa number na magpo-proceed with pursuing geotech in the future. So, ayun. Ayun, I think it's stopped na. I don't know. But yeah, thank you very much for participating and engaging. Sorry, ito na yung pinaka-limited na magagawa kong engagement with you all. I think kung face-to-face tayo, there's more activities that I can squeeze in. Pero for now, let's settle with these activities muna. So, pero naman, if in any specialization that you pursue, I think, and I believe naman lahat tayo dito magiging successful tayo in everything that we do. Basta lang, kahit na at some point sa career ninyo mahirapan kayo, I guess hindi din kasi ako naniniwala na pag na-enjoy mo dapat hindi ka mahirapan. No, actually magsa-struggle talaga tayo kahit gusto natin. Pero it's just that if we continue to choose it, to choose fighting for it, and ayun, magsasucceed talaga tayo. Not only to geotech, but other aspects in life as well. Kayo na bahala kung ano yun. So, ayun. So, we have 52 correspondents. So, thank you. So far, go geotech pa din. And hopefully, in the future, totoo pa rin to. So, with that, I think, I would show you all the references that I use for this presentation. And then, thank you very much for your attention. So if you have any questions, I think the floor is open naman ata for any questions that you might have. And I think we still have time to answer naman. So I turn it over muna sa host kung paano kayo kukuha ng mga kung may questions ba or what. So thank you.
Pag daw nga, nakabila mo na. Sakit talaga.
So, thank you so much for that incredible talk, Engineer Nicole. Grabe. Literal na we went deeper, di ba, Jordan?
Indeed, Ja.
So, sa tingin mo, ano bang favorite or most memorable part mo ng talk ni Engineer Nicole?
Para sa akin, Engineer Nicole was considerate enough to give us a sample geotechnical report. Na-enjoy ko yung mga practical applications ng mga courses natin. And naalala ko yung sa klase ni Sir C where we drew yung subsurface profile dun sa mga borehole logs. So, yun, naalala ko yun. And I love that. Shoutout sa mga kagrupo dyan sa lab.
Oh, grabe. Sobrang na-appreciate ko yung pagturo syempre sa software. Although, ang dami na nating software sa structural na
Tama ka dyan.
Parang ano ba naman yung isa pang software na, alam mo yun, alam mo na yung STAAD eh. So, alam mo na kung anong next na gagawin after ng STAAD. Hindi lang tayo, Hindi lang tayo tinuruan paano gamitin yung software, tinuruan din tayo paano basahin yung result. So, feeling ko kaya na natin gamitin yung AllPile na software. So, syempre, tayo nga interested. So, ang dami natin dito, 270 participants. Baka
May additional reminder ata tayo.
Pero ayun nga, baka may mga questions kayo. Pero before that, may additional reminder lang. For the protection of any information that has been disclosed in the seminar, students are advised that any data presented by the speaker are for academic purposes and for your eyes only. The discussed data should not be shared with others that haven't attended the seminar.
Thank you. For anyone who has questions or thoughts that you would like to share with the participants or to address to the speaker, Engineer Nicole, now would be the time. So send nyo lang sa mga chat box and kami yung bahala. Meron.
I think medyo shy yung audiences natin. No? Or baka siesta time na. Charot.
Baka hindi pa po sila nagla-lunch. Pwede naman po kayo mag-grab ng lunch habang...
Or baka nahihiya lang sila masyado.
Yes.
Baka nga nahihiya sila. Parang dapat may mangunang magtanong sa 4CEB. May gusto ka bang tawagin, Jordan?
Sino kaya? Sino dito? Ang daming 4CEB. Siyempre dito tayo yung sponsor. Pili ba ako?
Pwede naman.
Feel ko si Mr. Cabral.
Okay, Mr. Cabral daw, ang Vice President ng 4CEB. Paki-chat po kapag may question para masagot ni Engineer Nicole.
Hi, hello po. Good afternoon po sa lahat. May question po ako sa speaker natin, kay Engineer Tan.
Sige po.
Di ba, yun, geotechnical engineer kayo. So, ano pong masasuggest nyo na career plan para po sa mga gusto pa mag-pursue ng career sa geotechnical field?
Career plan?
Yes po. Or kung ano lang pong masasuggest nyo sa mga gusto pa mag-pursue?
Ayun, siguro have a very in-depth study of geotechnical engineering. As in, minsan kasi, ewan ko, sa career ko kasi, nangyari, parang mas nag-focus na ako sa software along the way. Kaso, yung mga basic na mga topics such as yung mga Atterberg limit dati, nakaligtaan ko at some point. Lalo na yung mga deriving engineering properties. So, have a good foundation on soil mechanics. Kasi yun yung usually, yung mga basic, yung mga kalimutan natin as we progress. Saka yun nga, dapat kailangan nyo ng talagang interest with geotechnical engineering. Kasi mahirap din naman pilitin kung hindi mo din naman mahal or gusto yung aanuhin mo. So, kailangan ikaw mismo may interest ka sa geotech. Tapos, geotechnical engineering is an ongoing study. So, kailangan up-to-date ka rin sa mga latest innovations, mga geotechnical problems. I think this also applies to other specializations. Pero ayun lang. Kailangan ng constant study and understanding about sa soil and sa kung ano mang modern day problems para maka-come up din tayo ng solutions as geotechnical engineers.
Thank you po.
May nag-direct message sa akin. Hindi ko alam kung ayaw niya ipasabi yung name, pero hindi ko na lang sasabihin. Sabi niya daw po, hi, available po ba yung software for free?
I'm not sure. Kasi yung software na to, meron akong license talaga. Actually, hindi niyo lang nakikita, may dongle na ano din sa laptop ko. Pero I'll try din to find student version nito para paglaruan ninyo if ever man maging kailangan ninyo. I think I'll be in close coordination naman with Jejomar about the presentation materials. So, i-inform ko na lang din sa kanya kung may nahanap akong student version nito. Ayun.
Oh.
So, I think meron din ata sa mga chat box.
Yes po. Ito. From Mr. Somilan po. What do you find the most challenging in your experience as a geotechnical engineer?
Ayoko sa settlement analysis. Ayun lang. As in, ayoko. Ewan ko, siguro wala akong deeper understanding kasi ng settlement analysis and may limited experience ako on that. So, nung binigyan ako, hindi ko makalimutan to kasi last year nabigyan ako ng isang port na project. Tapos, involved siya sa intensive settlement analysis talaga. Nablangko ako as in, parang I needed to go back to basics. Kaya yun yung nasabi ko kanina na kailangan may solid foundation kayo sa basic ninyo. Sa deriving parameters, lalo na sa mga settlement parameters. Naku, Diyos ko. Pero ayun naman, dahil nga sa experience din na yun, kinailangan ko din you have to adapt to the situation. Kailangan ko siyang aralin din talaga. Tapos, ayun, naging challenging siya, pero at the end, naging rewarding din siya kasi additional knowledge din for me and additional experience din. Kaya ayun, kung binigyan ako ngayon ng settlement analysis, siguro konting iyak na lang. Unlike yung before na, kasi ngayon, parang mas alam ko na yung gagawin. Alam ko na yung workaround. If ever man nagkaganon. So, ayun lang. So, next question.
Okay, question from Rafael Razon. Hi po, ma'am. Since geotech is needed in every civil works, paano po yung mga nagde-deny po ng paggawa ng geotech report, especially po sa small scale like residential house?
Oo. That's actually a ongoing issue rin until now. Pero kasi, if I recall correctly, pag more than 2-story yung house nyo, saka kailangan ng geotech report, sa City Hall requirement yun. Pero usually pag yun nga, dapat may preliminary study ka talaga eh. Pero ang nangyayari kasi ngayon, since small scale lang siya, tas residential house, yung iba kasi nababypass na. Kasi meron ka ng ibang boreholes din na nasa City Hall. Tapos from there, parang nagiging generalized na lang siya na soil condition, basta nasa within the area ka, gano'n. Pero for me talaga, mas okay pa din na may geotech report ka para maging efficient and optimize yung foundation system na gagawin natin on-site. Tapos ayun nga, para makita din natin kung may other settlement issue siya or expansive clays or other geohazards na potentially pwede mangyari sa future residential house. So ayun, in summary, kailangan pa rin talaga eh. Pero since minsan nga tight sa budget, na-overlook. Pero as a geotechnical engineer, essential din talaga na may site-specific study tayo for all the projects that we will be encountering. So, ayun. And may nag-DM pala sa akin, okay lang ba i-bring up ko na lang din? Na, paano ko daw nasabi na geotechnical engineering is for me? Siguro since undergrad, I found that the most interesting subject for me was soil mechanics. Nag-start siya sa soil mechanics. Ewan ko, it was very easy for me to understand compared sa mga theory of structures natin, sa mga design subjects. Hindi ko talaga kaya yun. Tapos parang yung dati pa lang mas napaglaanan ko siya ng time. Ewan ko, so personal interest ko talaga siya, kaya ako nasabi na geotechnical engineering is for me. Pero I think it doesn't apply din naman to everyone na kasi minsan yung may mga narinig din ako na geotechnical engineering is for them kasi mas konti tayo sa industry. Ayun, so lesser competition. Tapos ayun, yung mga ganong factors. Pero for me talaga, personal interest ko na siya since nung college pa. So, ayun. Meron pa bang question?
Meron pa
yes.
po. May mga DM pa po eh. Sorry.
Sige lang, go,
Nahihiya
go,
lang po
shoot.
siguro. So, from an anonymous sender. Good afternoon po. May idea po ba kayo mga how much yung geotech report for residential houses? So, inline po to dun sa kaninang question.
Geotechnical report for houses.
Ito po. Copy-paste ko po sa
Actually, wala akong ballpark na figure. Pero what I can say is, ang drilling works kasi, pagkaalala ko ngayon na, per linear meter, it actually depends kung ilang boreholes ka. Tapos kung kung saan yung location mo. Kunyari, yung drilling company nasa Las Piñas. Tapos yung bahay mo nasa QC. Mas malaki yung mobilization doon. Pero what I can say is, yung per linear meter ng drilling, it ranges from 3,000 to 8,000 pesos. Per linear meter yun So, assuming na, sorry, I need my calculator on this. So, assuming na 2 boreholes na 10 meter depth. So, 20 meters agad yun. Tapos, say 5,000 na lang yung median ng 20, sorry. So, 20 linear meters times 5,000. Ayun. So, aabot ata ng 100 plus? Tama ba yung math ko? Linear meter. Oo, mga ganun. Pero minsan, isang borehole lang. So, mga 30 to 50,000, mga ganun. Medyo, ayun nga, kaya nababypass din ang mga geotech reports kasi nga, mahal gumastos for a geotechnical report alone, sa drilling alone. Pero kasi, ang hindi na-understand ng ibang tao is kung may deeper understanding ka ng soil underlying subsurface condition mo sa site, ma-optimize lalo kung ano yung gagawin sa structure mo. Hindi ka lang nagre-rely mostly sa assumptions ng mga engineers na ganitong bearing capacity yung typical. Meron kang site-specific na bearing capacity na bigay. So in a way, ma-optimize yon pag nag-future develop ka ng bahay mo. So sa foundation, baka mas lumiit. Sa mga columns, sa mga beams, kanon. So ayun. Mahal talaga siya at first, yes. But it's definitely an investment. Lalo na if you want an efficient and optimized structural member sa bahay ninyo. So in the long run, in a way, makakatipid ka din. Mabigat lang talaga sa una. Pero makikita niyo yung impact niya as you go along the construction. So ayun, medyo maraming DM sa akin. So i-address ko muna yun sorry. Ayun, so may balak po ba kayong magtayo ng sariling business about geotech? That's an ongoing dream, pero for now kasi tinatapos ko yung MS ko. So I mean, I'm going to 5 years na ata ako nag-aaral. Parang may 1 year kasing nasayang dahil sa pandemic. So pero yes, I'm very open na magtayo ako ng sariling business ko about geotech. Talagang yung priority ko lang ngayon at the moment matapos study ko. But let's see after that. Baka parang meron naman. Tapos, ako na lang mag-ano ng mga questions. Sorry. Tapos, hi ma'am, ask ko lang po, in partner po ba ang Geotech at DPWH? In what part po kayo related? Sa soil lang po ba or in other ways? Actually, pag DPWH projects, kasi usually, soil lang. Sa mga na-encounter ko, so mga typical foundations, tapos mga geohazard study, ganun. Parang wala pa ako nakitang mga stability analysis na na-encounter. And sa Jacobs kasi, where I work with, we also limit our involvement with government projects. Kasi, ayun, siguro personal values and visions lang ng company ko. Pero wala akong masyadong idea about government projects. But definitely, siguro sa soil lang kami related. Wala pa akong nakitang stability analysis of some sort. So, ayun. May nag-DM din na madali po ba makapasok into geotech related job? For example, newly grad pa po. Actually, oo. With the right firms. Dapat hanapin niyo yung mga consultancy firms that really caters to geotechnical engineering na specialization. Yung dati kong work, AMH Philippines siya. So they are very open to fresh grads. Lalo na if, ayun, they are open to fresh grads. Tapos ang niche nila talaga sa market ay geotech. So parang meron silang internship program, kung baga. Si Sir Leo ninyo at saka si Sir Jerome Sinyo, doon din galing. Actually, doon kami galing. So, for starting up, tapos sa career ninyo, na kung gusto nyo mag-geotech, I think isang firm to consider is yung ano namin na yun, previous company. So, ayun, marami pang sorry host. Medyo nag-DM na din kasi sila.
May mga DM din po sa amin eh.
DM din. Sige, address ko muna yung DM ko dito, tapos sa inyo.
Sige po.
Okay. Good afternoon po. When you started in the geotechnical field, ano po yung scope of work na hinandle nyo? Ano po yung important for those na first time pala mag-work sa field or mga fresh grads po? So, ayun nga, yung nag-start ako sa geotechnical field, actually puro office works. Ayun, yung pinakita ko sa inyo, typical geotechnical report, so mga foundation analysis. Tapos as you go and gain more experience in those topics, saka kayo bibigyan ng mga slope stability analysis kasi mas complex naman yun na problems. Tapos after which, ayun na yung mga settlement analysis. So ano po yung important for those na first time pa lang? Lahat importante. Lahat importante. Pero ayun nga, siguro yung importante is I go back to my answer din sa first question. Dapat may solid foundation talaga kayo ng basics ng soil mechanics. And the rest will follow naman after nun. Yung sa field, I can't say much kasi limited lang din yung field work ko. Pero siguro important sa field, mag-sunblock kayo, maiinitan kayo. Tsaka ano siya, dapat medyo active kayo kasi pag nag-field ako usually sa mga mountainous areas. So dapat physically capable din kayo and hindi kayo ganun ka-arte. Kasi minsan mga remote areas pupuntahan natin. So lessen nyo lang yung expectations ninyo na laging maganda yung field work. Ganon. Minsan, lalo na for girls, limited yung CR. Tapos ayun nga, nakakapagod umakyat ng mountain minsan. Tapos buong araw kayo dun. So, i-ready nyo lang sarili ninyo. Dapat physically and ready kayo. Ayun. Tapos, ano pa ba? Ayun, sa tingin, ay si Dean De Alban. Hi, Dean! You also sent a direct message. So, thank you so much.
Hello.
Hi, Dean. Long time no see po.
Thank you.
Yes po. So his question is, when an investigation report is conducted, which somehow shows conflicts with the previously conducted geotechnical test report, what usually are some of the common factors that are considered overlooked by the previous tests or reports? So siguro, sa typical report na lang natin, usually in conflict siya sa previous. Kunyari, sa latest natin, mas madaming boreholes po yung na-drill. Tapos kasi yung, let's say yung previous test report, parang 2 borehole lang po na na-drill within the footprint nung structure natin. Tapos yung sa next geotechnical report, dinamihan po nila lalo yung borehole placement. Kasi po mahirap din po mag-generalize ng isang site condition pag 2 lang din po yung available ninyong borehole. So minsan sa next na geotech reports, may makikita kayo na discrepancies or additions na hindi nakita ng previous report kasi hindi din ample yung data na nakuha from before. Aside from that, factor as well would be the lab testing and soil sample handling. Kasi po minsan hindi na natin po monitor kung how the driller transport the samples in the lab test and how they carry out the lab test as well. So minsan nagkaka-problema nga din talaga sa information nung bago sa previous kasi nga pwedeng magkaibang dalawang laboratory yung nag-test. Tapos, ayun nga, minsan may mga sample mishandling din po na nangyayari. So, pag ganong information po, usually, minsan nire-reconcile na lang, ginagamit yung both data. Tapos, may mga notes na lang na there are some discrepancies, ganun. Tapos, mas ina-adapt yung newer. Lalo na kung yung newer naman mas madami pong boreholes na na-drill, tapos mas intensive yung lab test na ginawa sa mga soil samples. So, I hope po that answered your question po, Dean.
Thank you so much, Nicole. Thank you so much.
Thank you po. So, next question is si Angelic. Ay, sorry. Baka anonymous. So, sa tingin niyo po ba may necessary kumuha ng MS for Geotech kahit po may specialization na kami? That's quite interesting because previously we didn't have any specialization yung undergrad pa ako. So, I think baka necessary pa din kasi mas deeper, mas in-depth yung discussion pag MS. As in, mas theory-based din siya. Parang yung tip of the iceberg pa lang kasi inaaral natin pag undergrad. Sa MS, mas napupush ka to dig deeper sa theories kung paano nag-come up sa mga equations na yon sa ganitong assessment, ganun. So, saka ewan ko, parang okay din kumuha ng MS kasi makakakilala ka ng other professors na parang subject matter experts talaga. Kasi yung usually magiging prof mo sa MS, mga doctors. Doctor sa Geotech, so they have ample experience on-site and sa academe. Tapos baka mas makatulong din sila sa'yo sa kung ano mang specialization ng Geotech yung gusto mong tahakin in the future. Tapos, meron dito, hi ma'am, ask ko rin po kung magpro-provide po kayo ng copy ng report. Yes, of course, I will. I would coordinate with your organizers regarding that. Tapos, ayun nga, isasama ko doon yung AllPile na software if ever may student version. So, ayun, I guess that's it sa DMs ko. Meron pa bang DMs niyo?
Meron po, naka-anonymous din po.
Sige po.
Based po dun sa software na pinakita nyo kanina, on what circumstance po na dapat may incline yung pile? Hindi po ba mas maganda pag vertical lang?
Inclined piles usually are encountered pag mataas yung lateral force na nai-induce ng structures. Kasi pag axial ka, pag vertical pile ka, wala kang lateral resistance sa lateral loads. So kung mag-inclined ka, syempre meron kang y-axis and may x-axis ka. So may lateral resistance ka to resist yung lateral ng superstructure mo. So I've encountered that, yung mga battered piles na yan sa mga piers. Kasi sobrang lalaki din ng mga loadings doon, lalo na operational yung pier. So may mga crane loads ka, may mga vehicles na malalaki na nag-on. Tapos yung, hindi ko ma-explain kasi for coastal to, di ba may nangyayari na mooring and berthing ng mga boats sa mga piers. Ayun, nag-i-induce din kasi siya ng lateral load. So to summarize, ang mga inclined piles usually, nire-resist niya yung mga structures na nag-i-induce ng mga lateral loads, which can be found sa mga marine, sports, and maritime projects natin. Ayun.
Ayun. Thank you. Meron pong one last question before we move on po. Good afternoon po. What software do you use po when evaluating large amounts of boreholes? Does the program also have various features such as foundation analysis, settlement, and liquefaction analysis?
I've actually not yet used this, pero I think yung GINT, parang GINT siya na software. Tapos basically parang yun yung database mo ng mga na-retrieve mong boreholes from this area. As in, database lang siya ng borehole mo na meron ka per area. Tapos, pero yun nga lang, since database lang siya, hindi din siya capable of analyzing, yun nga, yung foundation analysis, settlement, liquefaction analysis. separate programs pa rin or separate spreadsheets pa rin yung ginagamit natin. Pero usually yung program na GINT na yun, ayun nga talagang storage, kumbaga storage lang siya ng mga borehole data. Kasi tedious din nga naman na i-input mo lagi yung borehole data tapos meron ka na palang gano'n na data sa GINT mo or yung naganda din ng GINT mo kasi yung GINT or Leapfrog ba yun? Basta may yung software na yun, mag-i-indicate ka lang ng boreholes doon. Tapos parang statically, ewan ko, by statistics something, magge-generate siya ng soil model mo sa area na yun. And the more boreholes that you input, the more na magiging defined yung soil profile ninyo. Tapos, kinaganda nun, ayun nga, na yung limited lang yung data mo dati, tapos pwede mo siyang dagdagan pa ng borehole hanggang sa ma-achieve ninyo yung desired na output ninyo and a more defined understanding of the subsurface dun sa study area. Yun lang.
Ayun.
So, may questions pa ba kayo?
Ano po? Press na po tayo for time eh.
Sige.
Madami pa po pero
meron pa po akong tatlong pending.
Sige, okay lang.
So sorry dun sa mga ibang tanong na hindi po nasagot.
Okay lang. So ayun, thank you for all your questions and I'll see you all in the industry soon. Kayang-kaya niyo yan.
Yeah, so, thank you to everyone who asked their questions. And of course, to our honorable speaker, Engineer Nicole, who gave her wonderful talk and addressed everyone's questions.
It was for sure an enlightening talk for the entire participants present this afternoon. We are very pleased to have gained more knowledge regarding the general practices of geotechnical engineering and how it gave perspectives applicable to our technical knowledge. Confidence flows through each one of us, knowing that these learnings could be applied as civil engineers of tomorrow. Inalang about sa bato ni Darnang nalalaman natin. With all the learnings we acquired, for sure, proud si Ding sa atin.
Hindi ka nagkakamali dyan, Jack. We, future engineers, will become heroes if apply natin lahat ng natutunan natin ngayon. Tulad ni Darna, di ba? Kulang na lang tayo ng red costume. Kidding aside, it was really a pleasure to learn more about Pile Foundation. With this, we want to portray our sincerest gratitude through the awarding of the Certificate of Appreciation. May we invite Engineer Nicole Lane Ditan to kindly open your camera for the acknowledgement. May we also invite our dearest professors, Associate Professor Josefine de Alban, Dr. Franz Kevin Geronimo, Engineer Oscar Conrad de Jesus, and Engineer Rajiv Eldon Abdullah to join us with the awarding. This certificate reads, the Certificate of Appreciation is presented to Engineer Nicole Lane Ditan for her valuable contribution as the event speaker at the online webinar with the theme Consolidation, Compressing the Nose and House in Geotechnical Engineering, given this 24th day of February in the year 2022. Signed, Engineer Rajiv Eldon E. Abdullah, Civil Engineering Department Chair, and signed, Professor Angelo R. De La Cruz, PhD, PECE, Dean of the Faculty of Engineering. So, yun po. May we call on Mr. Oscar Conrad de Jesus for a short message.
Good afternoon, everyone. First and foremost, I would like to thank my batchmate, Engineer Tan, for actually giving us her time in sharing her knowledge and imparting her experience as a geotechnical engineer. Well, actually, magkasabay kami ni Nicole in organizing them before yung sa ACES and then graduating and then meeting in UP wherein we encountered different majors since I'm an urban planner now. So with that, sa experience na binigay ni Engineer Tan, we can actually see that as engineers, we must uphold the safeguarding of the lives of the people since we know for a fact that lives are at stake kapag hindi natin sinunod yung mga guidelines na natututunan natin along the way, along with the knowledge na sinishare sa atin ng mga professors natin, and at the same time, yung practice na very honest practice dapat since mako-compromise talaga yung quality of life ng tao na gagamit yung mga structures na dinadesign natin along the way. And of course, makikita rin natin na with a very safe foundation or an engineered solution for something that is either simple or complex can actually make a better place for the people to actually live or to do their daily activities. So with that, ayun ulit, thank you ulit, Engineer Tan, for giving us your time and knowledge and perhaps wisdom for the students to actually use and apply in the future. So ayun po. With that, I would like to also ask Sir De Alban for a message to Engineer Tan.
Thank you very much, Engineer Nicole Tan, for sharing your time with us. Our students are definitely inspired. I'm so inspired, and we thank you for visiting the university and your message to all the participants from UST, from Xavier, from St. Louis. I think you are giving them the message that they can do what you have done, and they will also succeed like your success field life today. Thank you so much.
So thank you, Engineer De Jesus and Professor De Alban. May we take a picture with everyone who has participated here for the awarding. Okay na po ba, Dr. Manal? Okay.
Next page na po ako.
Ay, hindi pa po sa professors pa lang po yun. So thank you once again, Sir Oscar. Now it's our turn to shine. Show your appreciation to the seminar by joining in the picture taking. Please turn on your cameras and wait for the signal. So lahat po recommended mag-on ng cameras. Bilang na lang.
Hello. Okay na po ba?
Taking picture na po on 1, 2, 3. Next page na po ako. 1, 2, 3. Next page. 1, 2, 3. Next page. 1, 2, 3. Next page. 1, 2, 3. Last page na po. 1, 2, 3.
And there you have it. Grabe. The smiles on your faces look like you learned something interesting today.
I totally agree. Before we finally end, here's Mr. Jejomar Cabral, the Vice President of 4CEB, to conclude this program.
Good afternoon, everyone. I hope all of you are well. This has been a very informative talk with Engineer Tan, right? Truly, her knowledge about her field of expertise will be of great use to us once we are able to fully process and embrace them. Plenty of us here will, of course, take a different path in our careers. However, all of us are connected. In some way or another, there is a huge chance that we will be able to cross paths with one another once again. Just like the theme of this seminar, I hope that we will be able to consolidate the feelings and knowledge of each other and build a stronger foundation where tomorrow's society will soon be put up. To each and everyone who are here, our dear participants, advisors, professors, and administrators, most especially to our speaker, Engineer Nicole Tan, a big thank you from me and the rest of Section 4 CEB. Have a great day ahead.
Thank you for that, Mr. Cabral. Indeed, the seminar taught us more about the knows and hows of geotechnical engineer.
It has been a pleasure for us to have everyone, our professors, as well as our guests for today's event. Before leaving the Zoom meeting, we again remind you to answer the attendance form in the chat box below, and the evaluation forms will be sent through your respective class representatives.
All right, our deepest gratitude once again. This has been your host, Janina De Auna.
And Jordan Valdez of 4CEB.
Thank you and good afternoon.
Please be advised that after the singing of the UST hymn, you may leave the meeting.